The MeshCore developers and community have been hard at work, and firmware version 1.16.0 is here, which brings new tools for managing flood traffic, increased power saving for both ESP32 and NR52 based devices, a handful of new supported devices, and more. So let's go ahead and dig into it. And to kick things off, there's a number of new devices that now have support for MeshCore. Now, many of these haven't been officially released yet, so you won't find much info online about them or find them available for purchase just yet. Two of them are new card-style devices with the LilyGo T-Echo Card and the Heltec Mesh Node T1. Looking online, you'll find some Reddit posts from folks showing pictures of pre-release versions of each one. And here we have a post with the T-Echo Card and some side-by-side shots of it next to the T1000 from Seed Studio. Then there's also a Reddit post with some shots of the Heltec Mesh Node T1. There's also a small wearable device called the LilyGo T-Impulse Plus that now supports MeshCore as well. There's not a lot of info online about this one as well, but LilyGo posted a preview video of it on their Instagram. And as we can see here, it's a very small wearable device. And there's also some newly supported XIAO variants. And for you advanced users, the new Station G3 is now supported with MeshCore as well. There's now extended ACK packet support, and if you're unfamiliar, ACK is short for acknowledgement. And an ACK packet is what's sent during some communications on MeshCore, like direct messages, for example. When you send another user a direct message, their device will respond with an ACK packet to let your device know they received your message, which is what happens when you see the delivered status appear on the app. With this latest MeshCore update, these ACK packets are increasing from 4 bytes to 6. Those 2 extra bytes carry an extended attempt number and a random byte. Prior to this change, ACK responses maxed out at 4 attempts per direct message. But with the new extended attempt number, this allows for the ability for many more ACK response attempts for direct messages. This means better chances of your device receiving the ACK response and confirmation that your message was successfully delivered. Now, repeaters will need to be updated first, and this feature will come in a later app update. There's also a few power saving increases with this new release, starting with ESP32 based repeaters. And the key change here is repeaters now go back to sleep immediately after processing a LoRa packet. Previously, there was up to a 22-second delay before sleep, which on a busy network meant the repeater almost never slept. In addition to that, there's now power saving for NRF52 based devices flashed with the companion firmware. NRF52 based devices already have incredible battery life, but with this latest MeshCore release, they now use 30% less power than before, so you can keep your companion nodes up and running even longer. Now, we haven't covered the topic of region scoping yet, since that'll be covered in the new series of MeshCore videos we have coming soon. But to quickly explain the basics of it in a nutshell to those who are unfamiliar, this is a way to control flood traffic to prevent it from flooding the entire mesh. Things like adverts and messages and channels are sent using flooding. And with our mesh here in Tennessee, a message from a user in Tennessee would reach across North Carolina, Georgia, Kentucky, and Virginia. Right now we're not running into issues, but as the mesh continues to grow and we connect to even more states, this traffic flooding everywhere will eventually cause problems. And this is where region scoping comes in, and it allows repeater owners to set regional boundaries where they want repeaters to forward traffic to. We won't go too deep into it in this video, but be sure to hit that subscribe button and stay tuned for the next series of MeshCore videos for that. Now that we know the basics, let's go over 2 new repeater command line options that give repeater operators additional control over flood traffic on the network. The first is flood.max.unscoped. With region scoping, you can set region deny F, and that asterisk is basically saying to block all unscoped messages. But this can cause potential issues because new users who haven't set up their regions yet basically can't talk to anyone. Flood.max.unscoped gives you a better alternative to setting this deny F option and limits how many hops an unscoped flood packet can travel. The second is flood.max.advert. This limits how far advert packets flood across the network. Instead of the previous default of 64 hops, it now defaults to 8. Advert packets are large, and the goal is to reduce the background noise that flood adverts create by having a more reasonable default, while still letting operators increase the limit if their network needs it. While we're on the topic of region scopes, let's go over another new related command addition called region def. Previously, remotely logging on to repeaters to define regions in their hierarchies from the command line interface meant sending a separate command for each region. However, the issue with this is when you're remotely sending commands to a repeater that's multiple hops away on a busy network. When doing this, there's more potential for dropped messages to break the configuration process and require multiple retries, which will generate more network traffic. With the new region def command, we can now define an entire region hierarchy in a single command sent to the remote repeater. There's a command line interface reference at docs.meshcore.io you can check out for the full syntax, and I'll leave a link to this in the video description below. Also included in this release is a longer preamble for the lower spreading factors of SF8 and below. Now, to understand what this means, let's quickly go over what a LoRa preamble is. So every LoRa packet begins with a preamble, which is a series of upchirps in the signal. And this is something that other LoRa radios are listening for, and when they hear it, they lock onto it and prepare to receive the data. Now let's quickly go over what spreading factors are. So these are a LoRa setting that changes how long the LoRa chirps take to transmit. Let's take a look at this on an SDR for some examples of the difference. As we saw on the SDR, the spreading factor of 7 is much quicker than 12. Now, the longer the transmission, the further your signal can reach because distant stations have a better time of decoding these signals from the other radio noise that they may encounter on the band. However, these longer transmissions mean more airtime, slower speeds, which equates to less people being able to communicate before the mesh starts running into reliability issues. The spreading factors with faster speeds allow for more people to use the mesh, but you sacrifice distance. As we saw on the SDR, the packets using spreading factors of 7 and 8 are quite fast, and sometimes the repeaters aren't fast enough to lock on to the preamble at the beginning of the packet. So with this latest firmware version, the preamble length has been increased so that repeaters are more likely able to lock on to the signals. And we'll close out with a couple quick updates worth calling out. The default flood advert interval has changed from 12 hours to 47 hours. As mentioned earlier, advert packets are large, so reducing how frequently they get transmitted should noticeably reduce traffic across the network. For those of you unaware, MeshCore has firmware with KISS-TNC modem capability for connecting to packet radio software, and with this latest release, this capability has been added for most of the supported hardware. We'll get into more about what you can do with this when we get into the next series of MeshCore videos, so be sure to stay tuned for that. And that'll do it for this video on the latest MeshCore firmware release, and I hope you found it informative and helpful. If you did, please be sure to give the video a thumbs up and hit that subscribe button below so you don't miss out on more MeshCore videos coming soon. Thank you all and have a good one.